In this demonstration video, we showcase RDFpro, an open-source Java library, command line and web tool for single-machine RDF processing that leverages streaming and sorting techniques. RDFpro enables to perform several processing tasks on RDF quads, such as triple-level filtering and transformation, inference materialization, OWL CMS smashings, and statistic extraction. RDFpro processing model is centered around the concept of RDF Processor. An RDF processor consumes an input stream of RDF quads in one or more passes and produces an output stream of quads, having possible side effects such as reading and writing of RDF files. RDF processors can also be composed in complex pipelines to efficiently perform multiple parallel and sequential computations on RDF data in one or more passes. RDFpro offers a number of onboard RDF processors to perform I/O operation like reading RDF files and emitting their quads together with the input stream, to perform data transformation like transforming a quad in one or more quads or materializing infrared quads, and to perform data analytics such as emitting structural statistics on the input stream according to void guidelines. Additional processors can be added to extend the processing capabilities of the tool. So let's see RDFpro in action. This is the web interface of RDFpro. On the left side, you can see three main blocks. The first block enables to select the data to be processed by feeding the RDF stream with data coming from an RDF file in any popular serialization format, even in compressed form, manually provided data through a web form, or a preloaded example file extracted from DBpedia 2014. The second block enables to specify the RDF processors to be applied to the input stream. The list of built-in RDF processors available through the demo is shown on the right side of the interface. Autocompletion facilitates the typing of the available processors. Some predefined processing examples can also be recalled. Auxiliary files needed by some processors can be provided through the additional files uploading form, or can be chosen among the preloaded file list. The third block allows users to specify the format and compression of the output stream obtained after the processing. Users can also decide to get the results of the processing directly in the browser, ticking the Show Results in the Browser box. We will now showcase a few examples of RDF processing using RDFpro. In the first example, we will extract RDFS labels from an input file, asking RDFpro to remove duplicate quads. The input file consists of 36,000 triples about soccer players extracted from DBpedia 2014, contained in a TTL file. As you can see, the input contains many types of assertions, including type assertions, annotations, and many more. To extract only RDFS labeled triples from the input file, we apply the transform processor, specifying that we want to keep only quads having as property RDFS labels. We also apply a unique processor to remove any duplicate quads. We decide to get the output in the browser window in N3 format. This is the results of the processing performed. As you can see, it contains only RDFS label assertions. The second example will show how to transform some of the input quads and to materialize RDFS infrared quads in the output stream. We use the same input file as the previous example. The transformation we perform consists in converting to uppercase all the RDFS label in the file. This is done once again using the transform processor, invoked this time with a script that performs the conversion. To pass the script to the processor, we upload the file in the Additional Files box. This particular script is written in Groovy, but also JavaScript is supported. Once uploaded, we reference the script to be applied as argument to the transform processor. To materialize the RDFS infrared quads, we apply the rule processor, which executes the rules defined in a rule set against the input stream, materializing the infrared quads in the output stream. In particular, we use the preloaded RDFS rule set. We also tell the rule engine to use the T-box of DBpedia 2014 for materializing the infrared statements. This additional step is not necessary but allows for the optimization of inference rule before their evaluation. This time, we request the output as a gzip trig file. So let's see the results of the processing. As you can see, labels are now uppercase. In our last example, we will invoke RDFpro from the command line, which is more suitable than the WEM interface for processing large quantity of quads, even billions of quads. In this example, which showcases the great flexibility of RDFpro processor composition, we will merge a set of files from DBpedia 2014. In particular, we will first merge them as is, but we will also merge them after applying some RDF processors, and in particular ALSEM smashing, RDFS reasoning, and duplicates removal. For both merged files, we will also compute void structural statistics. So let's see the command. First, we use the read processor to specify the files to be loaded in the stream. Then, we start a parallel computation, as shown by the curly brackets. In the first parallel branch, we write the stream obtained by merging the three files as is. In the second parallel branch, we compute the statistics on the input stream, using the stats processor, and writing the resulting statistics in a separate file. In the third parallel branch, we perform ALSEM smashing on the input. Then we apply RDFS inference materialization, calling the RDFS processor, and using the auxiliary DBpedia ontology as T-box. And we also remove possible duplicates. We then route the stream to two distinct processors using another parallel composition. In the first nested branch, we invoke write to write the results of the processing to a file, while in the second nested branch, we compute the statistics on the resulting stream. We then close all open parallel branches. So let's run the command. As you can see, RDFpro starts reporting some numbers, in this case the number of triples processed and some execution averages. When done, we can have a look at the statistics on the resulting files, organized according to the void vocabulary. The statistics on the merged file as is, and the statistics on the merged files after the processing performed. Going back to the website, several examples of non-trivial data processing using RDFpro are reported in the example pages, where the full syntax of the various RDFpro invocation is also provided. RDFpro can also be used as a library in Java applications. A detailed Javadoc API documentation is provided. The code of RDFpro, which is released under the public domain license, is available for forking on GitHub. A precompiled binary is downloadable from the website. Besides tweaking some settings to optimize the execution performances, as documented below, running RDFpro from this binary is extremely simple. You just need to download the file and extract the package. RDFpro is ready to be used. The web interface previously shown is also released with RDFpro source code and is installable. For more details, please visit the RDFpro website.